Good morning, Kevin. I hope you're well. Today we're looking at trigonometry. Now, I don't want you to freak out. I know it sounds like a really hard word and you're probably a bit concerned by it, particularly not being on Miss Dunbar with this stuff. But we're going to try and go through one step at a time about trigonometry, explain to you kind of what it is, and then I'm going to reiterate or go back over the things that you really need to know. And the things you need to know today, there's not a lot. There'll be a bit of content, so I want you to listen. Don't write things down, just listen. If you need to pause it, go ahead, or you need to go back over it, you can do that as well. So do you know what trigonometry has anything to do with? Now, the most common answer someone will say will be, it's to do with triangles. And absolutely, Kevin, it is. Okay, we've just been looking at triangles, haven't we, with Pythagoras Theorem, where you're doing a squared plus b squared equals c squared. Well, this is a little bit similar. Now, if I show you a question, for example, something looks like this: 5 centimeters, x centimeters, and 30 degrees. Can you see why your Pythagoras wouldn't really work with this question? Well, your a squared plus b squared equals c squared, you only have one side in this case. We don't know what these two other sides are, so we can't really use Pythagoras. And that becomes a little bit challenging. So what we need to do, we need to use the topic of trigonometry. And there are 3 rules, or we call them ratios, but rules are just as fine. We use 3 rules to help solve this equation. Now, what will happen each time, you'll be given 2 pieces of information plus a third that you are trying to find. So, for example, we have a side and we have an angle and we're trying to find the other side. You'll always be given 3 pieces. And your rule, you'll simply be substituting into it. So what you're going to have to figure out, the biggest part is, which rule do I use? We'll give these 2. Now, I'll show them 2 to start off with. Don't freak out because, we'll go through this slowly in a little bit. We say sine equals opposite over hypotenuse. We say that cos theta equals adjacent over hypotenuse. And we say tan theta equals the opposite over the adjacent. Now, you might remember this a little bit from last year, but it's all good, okay? I don't think you do it in year no. Hi Kevin, I hope you're well. Today we are looking or investigating trigonometry. Now don't freak out, trigonometry, I know it's a little bit different, a little bit hard. You'll have never seen this before, and that is okay. I'm going to go through it slowly. The things that you need to get out of today, they're quite small. I'm going to show you a bit more, but don't freak out, okay? You'll have plenty of time and Miss Dunbar will go back over everything with you when you get back to school anyway. Now, first of all, my question generally is, what is trigonometry to do with? Okay, now you might look at the screen and say, maybe right-angled triangles. Okay, so far think about what you've been doing for the last 3 sessions. You've been looking at Pythagoras Theorem. Okay, a squared plus b squared equals c squared. Now that's all good and well, but the problem is, in this question on the screen here, this triangle, we don't have 2 sides in able to find the third. That's a bit hard. We know what the hypotenuse is, that's 5. We don't know what either of the smaller sides are. So we can't use Pythagoras. That's what trigonometry does. So trigonometry, in short, Kevin, it allows us to find the sides, or perhaps later on the angles, of a right-angled triangle. A little bit similar to Pythagoras, I guess. Now, there are 3 main rules that you will get to know over the course of this topic. You'll be given those rules. You don't need to remember them. You just need to know how to use them. They'll look very different to you at the moment. Sine theta equals opposite over hypotenuse. Don't worry at all. You might remember, though, you might have seen this on your calculator key. If you've got your calculator, have a look. Can you find the sine, the cos, and the tan? But cos theta equals adjacent over hypotenuse. And the last one that we'll be using will be tan theta equals opposite over adjacent. Now, again, You don't need to know those just yet. I'm just saying that's what we'll use. Later on, we'll use these rules to apply it to this question to be able to find out what the side is. Now, you'll see in each of these rules, right, there are three things that's going on, apart from the sine, the cos, the tan. Do you remember what this little symbol's called? Now, we call that symbol theta, okay? It's like a little O with a little line through it. And what that means is, it means an angle, okay? An angle of some description. Now, in my triangle, you can see here, the theta would be the 30 degrees. Just means an angle. It's like having an X or a Y, but we use it with angles. We also have something that says op. That means opposite. That talked about the side that is opposite the angle given. So in my triangle, could you figure out which is the side that's opposite to the 30 degrees? You might say that one there, and you would be absolutely spot on. That's the opposite side. Then we have the hypotenuse, hype, and we've been doing that a fair bit, haven't we, in Pythagoras? It's that longest side, okay, the hypotenuse. Now, there's another side that some of the other rules might use. They don't use it for the first rule, but you've got this ADJ, and that's called the adjacent side. And adjacent means next to. So for example, this side here would be adjacent. It would be next to the 30 degrees. So I'm just introducing these three little words to adjacent, hypotenuse, and opposite side. And what our aim will be, to start off with, will be to label the sides, okay? Because once we figure out, and this instance I'll show you to start with, if we work out that we're using the opposite side and the hypotenuse side, well, there's only one rule that uses those two. And we would work out that we would be using the sine rule. If we had the adjacent side and the hypotenuse side, we'd use the cos rule. If it was the opposite and the adjacent, we'd use the tan rule. And that will become more sort of apparent as we go through. But I'm just going to now take a tack and just show you some stuff. Don't write this down, by the way. This is the stuff I want you to kind of understand. Now, if you have your calculator, you can grab your calculator out, okay? Now, you'll see on your calculator, you'll see that, I'll start with sine actually. You'll see we have this sine key, this cos key, and we'll have this tan key. Now, let's start by looking at this 53 degrees at the bottom. And what we're going to do, we're going to calculate the value, calculate the value of sine 53, of cos 53, and of tan 53. So what I want you to do, Kevin, I want you to get your calculator out, see where the SIN button is. It's above the bracket key. It's on the second bottom row, okay? So I'm going to press sine, I'm going to type in 53 and press equals. And it comes out to be something like 0.7986. Now, let's just call this to one decimal place. We'll say 0.8, just to make it a little bit easier, okay? If I did cos 53, I'm going to type in cos 53 and press equals. We come up with an answer of 0.6018. Let's just call this 0.6 to one decimal place. And I'm going to type in tan 53. I'm just typing in some calculations here. And that gives me 1.327. Let's just call that 1.3 to one decimal place. So let's just look at these numbers. Now, again, you don't really need to know why I was doing those things, but if you need to calculate those things in your calculator, just press sine and you write your angling, okay? Whether it be sine 53, cos 53, or tan 53. One of the issues you will have, Kevin, of course, is that you'll see that a lot of these questions have lots of decimal places, therefore we will have to round. Now, there was a dude a long time ago, way smarter than me, okay, who figured something out. He figured that when I typed in sine 53, for example, we got this number of 0.8. And then he looked at the side that's opposite the 53, and he put that over the hypotenuse on his calculator and did 4/5, and guess what that came out to be as a decimal? He worked out that that was the same value. Likewise, when he pressed cos 53, he got 0.6. On his calculator, he typed in the adjacent side over the hypotenuse side, which is 3 over 5, and he came out with 0.6. Well, that's pretty cool. And then to finish off with, he pressed tan 53, got 1.3, and on his calculator, he typed in the opposite over the adjacent, which is 4 over 3 in this one, and it came out to 1 decimal place to be 1.3. A very smart guy. Now, again, that might not make any sense to you, and that's fine, but I'm just going to come back up to these rules. All the way up here, you can see them, and that's what he worked out. He worked out when he pressed the sine button that it always equaled the same as doing your opposite over hypotenuse. When we did the cos button, it always came out to be adjacent over the hypotenuse. When we did the tan button, it always came out to be the opposite over the adjacent. So this was a kind of the way that he came up with these rules. Now, I'm just going to show you this, right? You don't need to know this just yet. I'm just going to explain what he would do. He would then say, okay, I know it's the sine rule. We had the opposite over the hypotenuse. So he'd write down sine theta equals opposite over hypotenuse. He knew that those two things were equal. If he knew that the angle was 30 degrees, for example, and he typed in x over 5, what he did, he created an equation. Can you remember when solving your equations, Kevin, what the opposite of divided by 5 is? It might be times by 5. And on his calculator, he simply said 5 times sine 30, and he pressed equals, and it came out to be 2.5 centimeters. So what he essentially did, he used this rule to go and find the value of x. Now, that's all quite a lot to take in at the moment, and that's okay. So what we will have to do today, we want to be able to given a triangle, and we want to figure out what are the two sides called. Are they called the adjacent, the opposite, or the hypotenuse? And then we've got to work out which rule would we use. That's all we want to do. I don't want to do any of these equations, any of this. We'll do that later down the track. Today, it's all about getting a triangle, label the two sides, opposite, adjacent, hypotenuse, and which rule would I use. Now, of course, these rules are quite long, and I understand that. They will always be given to you, I'll say that. However, sometimes people will use this little term, and I will share it with you because the boys in your class will do it as well. Sine they call SOH, sine opposite over hypotenuse. Cos they call it CAH, cos adjacent over hypotenuse, and tan they call it TOA, tan is opposite over adjacent. And if I link it all in together, they call this SOHCAHTOA. SOHCAHTOA. And it just helps us to remember the rules. But for us, to be honest with you, I'll use SOHCAHTOA a lot, but you'll be given these rules all the time. Okay, I want you to make sure of that. So what do I want you to be able to do today? Well, these are the 6 questions that we're going to be solving. Okay, label each side as either opposite, adjacent, hypotenuse, and then choose which rule you would use. We're going to go through these together. Okay, the very first one, in regards to the 60 degrees, we have been given, now is that opposite or is that adjacent? Hopefully you can see that is the opposite side. The 15 would be the hypotenuse. Now, a lot of people think it's adjacent because it's next to, but remember, it's the longest side. Should be the easiest one because it doesn't really change. Now, yes, the bottom one, of course, is called the adjacent side, but you know what? I only want to write down the ones that I've been given values for, the 15 and the x. B, which sides have we been given? Well, the 10 is called the hypotenuse, isn't it? What about the A? Well, this time it's next to 40 degrees, so we're going to call this the adjacent side. There we go. We do have the opposite side, of course, but it's not given to us. It's not labeled. Oops, not labeled, so I'm not going to do anything with it. It's going to put the hypotenuse and the adjacent. And the last one, Kev, we've got the opposite side is the x, so I'm going to put opposite there. And then the 10 is the adjacent. And notice we don't have the hypotenuse, so I'm just going to leave it. Now, they're the first three things that I want you to be able to achieve. Can you label those two sides? Opposite, adjacent, hypotenuse. So that's the first thing that we're doing there. Opposite, adjacent, and we've got hypotenuse. Okay. The second part of this says, which rule would you use out of sine and cos and tan? So again, we're going to go through this together. Now, before we do this, of course, what I'm going to write down here is that rule. So, ka, and then toa. So remember, the rule states that sine of my angle, sine theta, equals my opposite over my hypotenuse, hence why it's SOH. Cos theta equals my adjacent side over my hypotenuse, and toa, or tan theta, equals opposite over adjacent. Can you see how it's the soccer toa? So if I look at the very first one, which of those three rules uses hypotenuse and the opposite side? Well, hopefully what you'll see is that's the very first rule. That's my sine rule. Okay, that's all I want you to be able to figure out. Okay, now if you want if you wanted to be extra, do a little bit extra work, what you could do, and this is what we'll be doing next lesson, you could write out the rule with the degrees in there and with the lengths in there. That's my rule, of course. You might like to write out sine 60 degrees equals the opposite side over the hypotenuse side. You can do that if you want, but we're jumping a bit, but that's okay. So all I've done there is I've taken my rule and I've placed in the three pieces of information. The 60 degrees where the theta went. I put the 15 where where the hypotenuse was. And the x, of course, where the opposite was. And we just plug those in. That's a good thing to start doing if you feel up to it. Now, if we look at B, we had the hypotenuse and the adjacent, or the adjacent and the hypotenuse. And look at that. It's the one directly above it. How convenient. It's my cos rule. So cos theta equals adjacent over hypotenuse. Now, of course, change color there. Of course, if you want to plug your angle in, you can say cos 40 degrees. If you want to put it in your adjacent, which happens to be A in this instance, and the hypotenuse, which is 10, then again, you can do that. That's a bit extra, but if you understand that, that's okay. Hard thing, of course, is to remember these rules, SOHCAHTOA, but you will be given them. Okay, the last one, opposite and adjacent. Well, look at that, odds on, it's the one above it, it's the TOA, because it uses the opposite and the adjacent. So tan theta equals my x, actually I'll use the rule, uses the opposite, so opposite over adjacent, so that's TOA, TOA. I'm then going to write underneath tan 50 degrees equals my x over my 10. Okay, I'm not doing anything more than that, I'm just doing that. Okay, now I'm going to just do this. Would you like to perhaps, if you want to pause it, you feel up to it, you can do this, or you can just kind of go through with me as well. So let's label the 47, so the D. So 47 degrees. Okay, so what are my two sides? We'll come back to the rule. Might get a little bit of space here just so I can drag some room down. Okay, so we have the 47 degrees. We have the hypotenuse, of course, up there. What's the x? Is that adjacent or opposite? Hopefully you said adjacent. So let's think of our rule. SOH, so, sine opposite of hypotenuse. CAH, cos, adjacent over hypotenuse. And tan is TOA, TOA, tan's opposite over adjacent. Which rule uses the adjacent and the hypotenuse? Well, there you go. You can see it's the Cos rule. That means cos. So that's my cos theta equals my A, which is my adjacent, and my H, which is my hypotenuse. And I'm going to write straight down and say cos 47 degrees equals my adjacent, which is X, over my hypotenuse, which is 10. And that's all I want to do. Nothing more. Perfect. What about the next one? There's my angle. Ooh, it's up the top this time. Okay, so what is the X called in comparison? Well, it's called the opposite side. And what about the 10? Well, it's not the hypotenuse, so it must be the adjacent side. Can you remember out of these three rules which uses opposite and adjacent? Well, there you go. It's that last one, TOA. So let's write it down. Tan theta equals opposite over adjacent. Okay, let's now go one step further. I'm going to write the angle in of 70 degrees. Now my opposite side is the X and my adjacent side is the 10. That's all I'm doing, nothing more. I'm not doing any calculations, just doing that. My last one, let's see how you go with this one. Okay, well, I don't have the hypotenuse, do I? So we've got the 10, which is called the opposite side, and the adjacent would happen to be the X. So which rule uses, actually we'll do the rule again, so, ka, toa. Okay, so we've got the O and the A, there we go, it's toa again, tan. So tan theta equals my opposite over my adjacent. I'm going to rewrite that, tan. Now my angle is 50 degrees. My opposite side is 10 and my adjacent is X. Again, I'm not doing anything with that, just writing my rule out. Now I know we've been 22 minutes, it's been a long lesson for you, but this is the first time you've ever seen trigonometry. So my first question again to reiterate is, what is trig about? Well, it's finding sides and angles in right-angled triangles. Well, right angle for us. Okay. The two things out of today is I want you to be able to be given something like this, a nice right-angled triangle. I want you to be given, two sides like this, for example. The two things I want for you is to be able to, first of all, label the sides. Now, when I say label the sides, opposite, adjacent, or hypotenuse. In this instance, what would they be? The A would be the opposite side, and the 6 would be the hypotenuse side. That's the first thing. Number 2, I then want you to choose the rule. Now, when I say choose the rule, that's out of so, ka, and toa. So in this instance, what would the rule that you would choose? Well, it's opposite and hypotenuse, so we would identify the first one, and that would be our sine theta equals our opposite over our hypotenuse. The third part of this now will be to apply the rule. And what I mean by that is substituting the values in, which you were doing before. So in this case, the angle is 40 degrees. The opposite, of course, is A, and the hypotenuse is 6. Now, that's a lot of stuff to do so far. Next lesson, we'll work on number 4, and that will be to solving that equation. That means getting rid of the 6, putting it to the other side, and then typing in that 6 times sine 40. Now, again, a lot to learn today. Please have a look at the worksheet that I've given you. Any problems, of course, Canvas, message me or speak to someone of the teachers down there. I said, or one of the other boys might be able to offer some assistance as well. But think about so, ka, toa, okay, opposite, adjacent, hypotenuse, and which rule would I choose? Next lesson, we'll work on actually solving the questions. Have a wonderful day. I hope you're enjoying your time there.